Hello everybody, this is Digital Blackboard by Sachin Nagmote, and here we are going to solve one problem of superposition theorem. So already many videos are uploaded that what is superposition theorem and how to solve the numericals of superposition theorem. The link of these videos are already given in the description. So this is the circuit given to us, and here we have to find out the current I using superposition theorem. Now, superposition theorem is applicable only when there are multiple sources in the circuit. So in this circuit, there are three sources, 8 volt, 6 volt and 2 ampere. So two voltage sources are there and this current source is there. So in step number 1, we will consider one source only. So let us consider 8 volt. So 8 volt is active. So 2 ampere has to be deactivated and 6 volt has to be deactivated again. So this 6 volt has to be short circuited because it's a voltage source, and this 2 ampere has to be open circuited because it's a current source. Now in step number 1, we will mark the current as I dash. So now we have to find out the value of this I dash. Now we will think that how current will flow in the circuit. So current will come from this 8 volt positive terminal of this 8 volt, and it will flow like this. So it will flow from 6 ohm and then through 2 ohm and then through 8 ohm. So this 6 ohm, 2 ohm and 8 ohm are coming in the series. So simply by using Ohm's law, we can find the value of this I dash. So that is V by Req. So 8 upon the equivalent resistance is the series combination of these three resistors. So 6 plus 2 plus 8. So 8 by 16. So finally I dash is 0.5 ampere and it is from left to right. So step 1 is over. We got I dash. Now in step number 2, we will consider this 6 volt acting alone, and this 2 ampere and this 8 volt has to be deactivated. So this 8 volt has to be short circuited because it's a voltage source, and this 2 ampere has to be open circuited because it's a current source. Now again we will think that how current will flow in the circuit. So current will come from this positive terminal of 6 volt. So current will flow like this, and in step number 2 we will mark the current as I double dash. So current is flowing like this. It is flowing through this 8 ohm and through this 2 ohm and through this 6 ohm. And after marking the direction of this current, we came to know that the direction of this I double dash will be from right to left. So let us change the direction of this I double dash. So I double dash is flowing from right to left. So simply this 8 ohm, 2 ohm and 6 ohm are connected in series. So simply by using Ohm's law, we can find out the I double dash V by Req. So it will be 6 upon 6 plus 2 plus 8. That is the series combination. So 6 upon 16. So I double dash is coming to be 0.375 ampere, and it is from right to left. That's why we have marked the arrow from right to left. So step 2 is over. We got I double dash. Now in step number 3, we will consider 2 ampere and we have to deactivate this 8 volt and 6 volt. So both are voltage sources. So we have to short circuit both the voltage sources. And now the name of the current will be I triple dash. Now we have to find the value of this I triple dash. Now this is a current source and this is practical current source because in the parallel of this 2 ampere current source, a resistor is connected. So it's a practical current source. So let us convert this practical current source into its equivalent practical voltage source. So the value of voltage source will be V is equal to IR. So 2 into 2. So the equivalent voltage will be 4 volt, and the resistance, internal resistance will be of this 2 ohm only. So this is the equivalent practical voltage source of this given current source. So 4 volt, and in series the internal resistance is of 2 ohm. So we can replace this current source by this voltage source. So we are connecting this voltage source over here. Now circuit is like this. So again we will find out that how current will flow in the circuit. So current will come from this positive terminal and it will flow like this. So again we can find that 2 ohm, 8 ohm and 6 ohm are connected in series. So simply by using Ohm's law, I triple dash is equal to V upon Req, that is 4 upon 6 plus 2 plus 8, that is 4 by 16. So I triple dash is 0.25 ampere and the direction of this current is from left to right. So we got I triple dash. So in 3 steps, we got I dash, I double dash and I triple dash along with its direction. So according to superposition theorem, the total current will be the summation of individual source current. So I dash plus I double dash plus I triple dash. So I dash, it is from left to right, I double dash is from right to left, and I triple dash is from left to right. So as the direction of this I double dash is opposite to that of I dash and I triple dash, we will mark negative sign to the I double dash. So that's why total current I will be equal to 0.5 minus 0.375 plus 0.25. We mark the negative sign to this I double dash because its direction is opposite to I dash and I triple dash. And that's how the total current is coming to be 0.375 ampere, and the direction is from left to right. So here we solve this problem using superposition theorem. So I hope you understood this problem very well. So like, share and subscribe Digital Blackboard. Thank you very much.